Welcome to Astronomy Daily, your source for the latest developments in space exploration and astronomical discoveries. I'm your host, Anna, and today we're diving into some fascinating stories from across the cosmos. The universe never ceases to amaze us, and today is no exception. We've got a packed episode covering everything from activities in our own backyard to discoveries that could reshape our understanding of distant worlds. First up, we'll look at SpaceX's second attempt to launch a brand new Falcon 9 booster, after an abort halted its first try. This Starlink delivery mission represents the fourth new booster brought into service by SpaceX this year alone, highlighting the company's continued expansion of its launch capabilities. Then, we'll turn our attention to a house-sized visitor making a surprisingly close approach to Earth. Asteroid 2025 KF will pass between our planet and the Moon on May 21st, coming within just 71,700 miles of Earth's surface. While there's absolutely no danger to us, it provides an interesting opportunity to discuss these rocky wanderers and how astronomers track them. Our third story tackles a critical challenge facing our technological civilization: the limitations in predicting solar storms. Despite significant advances in space weather forecasting, scientists are still struggling to determine the magnetic orientation of incoming solar storms until they're practically on our doorstep. We'll explore why this matters and what's being done to improve our early warning systems. From there, we'll journey to the asteroid belt, where exciting new research suggests that Ceres, the largest object between Mars and Jupiter, may be hiding a frozen ocean. And finally, we'll examine fresh research suggesting that terraforming Mars, transforming the red planet to make it habitable for Earth life, might be more feasible than we thought. So let's blast off into today's cosmic news roundup, starting with SpaceX's latest launch attempt. SpaceX is making another attempt today to launch a brand new Falcon 9 booster after an unexpected abort halted yesterday's countdown. The new booster, designated B-1095, was scheduled for liftoff from Space Launch Complex 40 at Cape Canaveral at 11:19 p.m. Eastern Daylight Time, carrying 23 Starlink satellites destined for low Earth orbit. Monday's launch attempt was automatically aborted with just under 2.5 minutes left in the countdown. Following the scrub, SpaceX engineers lowered the rocket into a horizontal position to address the issue. Though the company didn't publicly specify what caused the automatic abort, they did confirm that both the vehicle and its payload remained in good condition. By late Tuesday afternoon, B-1095 was back in its vertical position at the launch pad. Weather conditions looked extremely favorable for the rescheduled launch, with meteorologists from the U.S. Space Force forecasting a 95% chance of acceptable conditions during tonight's brief launch window. Their only slight concern was the possibility of cumulus cloud formation that could violate launch criteria. This mission is particularly notable as it marks the fourth time this year that SpaceX has brought a brand new Falcon 9 booster into service. The company currently maintains 18 other active boosters in its fleet, though one of them, B-1072, has only flown once as a Falcon Heaviside booster during last month's GOES-U weather satellite launch. The Falcon 9's payload fairing contains 23 Starlink satellites, with 13 of them specifically equipped for direct-to-cell phone communications capabilities. This represents an important expansion of Starlink's service offerings beyond traditional satellite internet. As with most SpaceX launches these days, the plan includes a landing attempt for the first stage booster. Approximately 8 minutes after liftoff, B-1095 will target a precision touchdown on SpaceX's drone ship, just read the instructions, stationed in the Atlantic Ocean. If successful, this will mark the 121st landing on this particular vessel and contribute to SpaceX's impressive tally of 449 booster landings to date. The deployment of the Starlink satellites is scheduled to occur about 65 minutes after launch, once the second stage reaches the proper orbit. These new additions will join the growing Starlink constellation that now numbers in the thousands, providing internet coverage to users around the globe. Next up, a little warning, but there's no need to panic. Our solar system is serving up another close cosmic encounter this week, as astronomers have just spotted a house-sized asteroid on track to zip past Earth tomorrow at an uncomfortably close distance. This newly discovered space rock, designated 2025 KF, will pass between Earth and the Moon on May 21st. The asteroid will make its closest approach at approximately 1:30 p.m. Eastern Time, coming within a mere 71,700 miles of our planet. To put that in perspective, that's less than one-third the distance between Earth and the Moon. While that might sound alarmingly close, NASA has confirmed that the asteroid poses no danger to Earth. During its flyby, 2025 KF will be traveling at a blistering speed of nearly 26,000 miles per hour relative to Earth. Its trajectory will take it closest to our planet's south polar region before continuing along its solar orbit. The asteroid's estimated diameter ranges between 32 and 75 feet, making it roughly the size of a modest house. What's particularly interesting about this asteroid is how recently it was discovered. Astronomers at the MAP project in Chile's Atacama Desert only spotted it on May 19th, just 2 days before its close approach. This highlights one of the ongoing challenges in asteroid detection. Sometimes these smaller objects aren't identified until they're practically on our doorstep. Even if 2025 KF were on a collision course with Earth, which it absolutely is not, its relatively small size means it would likely burn up in our atmosphere before reaching the ground. According to NASA, objects of this scale pose essentially zero threat to people on Earth. While close passes like this might seem rare, they're actually quite common. NASA has cataloged nearly 40,000 near-Earth asteroids since it began systematically monitoring the skies in 1998. Of those, about 4,700 are classified as potentially dangerous asteroids, though scientists at the Center for Near-Earth Object Studies have reassured us that no asteroid capable of causing widespread damage is expected to strike Earth in the next century. For context, 2025 KF's approach, while close, doesn't come anywhere near breaking records. The closest documented asteroid flyby occurred in 2020 when a car-sized asteroid passed just 1,830 miles from Earth's surface. That's less than the distance from New York to Las Vegas. This latest cosmic visitor serves as another reminder of the dynamic nature of our solar system neighborhood and the importance of continued asteroid monitoring efforts to keep track of our celestial surroundings. And another warning today. Imagine you're preparing for a major storm heading your way. But here's the catch. Meteorologists can tell you when it will arrive, but they won't know how severe it will be until it's practically on your doorstep. That's essentially the challenge scientists face when it comes to predicting solar storms. And it's a problem with potentially massive implications for our technology-dependent world. We've made remarkable progress in understanding space weather over the years. Scientists can now spot solar storm eruptions at their source, track their journey through space, and estimate when they'll reach Earth, sometimes with up to 24 hours of advance notice. But there's one crucial piece of information that remains frustratingly elusive until the very last moments: the orientation of the storm's magnetic field, known as the BZ component. When a coronal mass ejection, or CME, blasts from the sun, it carries along plasma and magnetic fields. The orientation of these magnetic fields determines how strongly they'll interact with Earth's own magnetic shield. A southward-oriented BZ connects more easily with Earth's field, allowing solar energy to pour in, which can supercharge auroras at best, or at worst disrupt satellites, radio communications, power grids, and GPS systems. A northward-oriented BZ, meanwhile, might pass with minimal impact. The problem is that scientists currently can't determine this critical orientation until the storm is measured at what's called Lagrange Point 1, or L1, a position about 1,000,000 miles from Earth in the direction of the sun. At that point, we have just 1 or 2 hours of warning before potential impacts occur. Solar physicist Valentin Martinez-Pillay puts it plainly: we need to start predicting what BZ is going to be as soon as the CME has occurred, not when we measure it at L1, where we only have 1 or 2 hours warning. What makes this particularly concerning is that our vulnerability to space weather is actually increasing. The sun itself isn't changing its behavior. It's been firing off solar storms for billions of years. What's changed is our reliance on the very technologies most susceptible to these solar disruptions. Most of our current monitoring comes from a single vantage point spacecraft positioned at that L1 point I mentioned. These missions, like NASA's ACE and Discover satellites, can detect solar wind properties and measure the all-important BZ component, but only when the storm is already nearly upon us. To truly forecast the strength of a solar storm before it hits, we need earlier measurements from multiple angles. Ideally, scientists would position satellites at various Lagrange points around the Sun-Earth system to observe these magnetic structures from different perspectives while they're still developing. According to Martinez-Pillay, the models are there, so we know the equation we have to solve, but we don't have good data. He predicts it could take about 50 years for space weather forecasting to reach the same accuracy and predictability as Earth weather predictions, assuming we make the necessary investments. But waiting half a century might be too late. While extreme solar storms like the famous Carrington event of 1859 are rare, they do happen. If a similar event struck today, it could cause trillions in damage globally by disabling satellites, knocking out power grids for weeks or months, and severely disrupting communications and aviation. We've already had at least one near miss in recent memory. In July 2012, the Sun fired off a colossal CME that would have caused devastating impacts, except it missed Earth's orbital position by just 1 week. As one researcher put it, if that eruption had happened just a week earlier, we would still be picking up the pieces technologically a year later. The stakes are high, and the scientific community is increasingly aware that expanding our space weather monitoring capabilities isn't just about scientific curiosity. It's about protecting our modern technological infrastructure from one of nature's most powerful phenomena. Looking toward the future, several promising developments may significantly advance our ability to predict and prepare for solar storms. One of the most anticipated projects is the European Space Agency's Vigil mission, scheduled to launch in 2031. Vigil represents a major breakthrough in our solar monitoring capabilities because of its unique vantage point. Unlike our current observatories that sit at Lagrange point 1 directly between Earth and the Sun, Vigil will position itself at Lagrange point 5, a stable orbital location that trails Earth in its orbit around the Sun. This sideways perspective will allow scientists to observe solar eruptions from an entirely different angle, providing crucial data about the shape, speed, and most importantly, the magnetic orientation of CMEs before they head our way. From L5, Vigil could potentially give us up to a 1 week's advance warning about incoming solar storms and their magnetic properties, a massive improvement over our current 1 to 2 hour window. As Martinez-Pillay noted, it's better than nothing. But the vision for comprehensive space weather forecasting extends well beyond a single satellite. The ideal monitoring system would include spacecraft stationed at multiple Lagrange points, L1, L3, L4, and L5, creating a network of sentinels watching the Sun from all angles. This distributed approach would provide continuous observation of solar activity regardless of which side of the Sun is facing Earth. While establishing such a network would require significant international cooperation and investment, the technology to build it exists today. What's lacking is the prioritization and funding that matches the actual risk these solar events pose to our global infrastructure. The vulnerability of our modern world to severe space weather can't be overstated. A direct hit from a Carrington-level event could disable satellites controlling everything from GPS navigation to telecommunications. Power grids across continents could collapse as geomagnetically induced currents overwhelm transformers. Air travel would be disrupted as both communications and navigation systems fail. Banking systems, internet infrastructure, and essential services all depend on technologies susceptible to space weather effects. The economic impact of such an event has been estimated in the trillions of dollars, potentially exceeding the damage from the most severe natural disasters or pandemics. Unlike earthquakes or hurricanes that affect specific regions, a major solar storm would impact entire hemispheres simultaneously. What makes this risk particularly concerning is that our historical record of solar activity is relatively short. The Carrington event of 1859 remains our benchmark for extreme solar storms, but the Sun has likely produced even more powerful eruptions over its billions of years. We simply don't know how bad it could get. Space weather scientists frequently remind us that the question isn't if another extreme solar storm will hit Earth, but when. The probability of a Carrington-level event occurring in the next decade is estimated between 1% and 2%, while the chance of one hitting in the next century approaches certainty. These aren't comfortable odds when weighed against the potential consequences. The good news is that with proper monitoring and warning systems, we could take protective measures. Satellites could be put into safe modes. Power grid operators could implement load balancing to prevent cascading failures. And critical systems could be temporarily isolated or hardened against electromagnetic effects. But these mitigations depend entirely on having adequate warning time, precisely what current systems can't provide. As we continue developing our technological civilization, expanding our space weather forecasting capabilities isn't just prudent. It's essential for protecting the infrastructure that underpins modern society. Moving on, let's take a look at a secret that's been uncovered in our own backyard. Tucked between Mars and Jupiter, the asteroid belt's largest resident has been hiding a fascinating secret. Ceres, a dwarf planet first discovered in 1801, may be far more watery than scientists have believed for centuries. According to groundbreaking research from Purdue University and NASA's Jet Propulsion Laboratory, this seemingly dry, cratered world might actually be a frozen ocean planet with an ice-rich composition that rewrites our understanding of its formation and evolution. For decades, the scientific consensus held that Ceres was predominantly rocky, with ice making up less than 30% of its mass. But this new study, published in Nature Astronomy, proposes a dramatically different picture, suggesting that up to 90% of Ceres' outer layers could be composed of ice. We think that there's lots of water ice near Ceres' surface, and that it gets gradually less icy as you go deeper and deeper, explained Assistant Professor Mike Sorey, who co-led the research with PhD student Ian Pamerlow. Their computer simulations tested how Ceres' surface has evolved over billions of years, revealing unexpected findings about the dwarf planet's composition and behavior. The key insight came from studying Ceres craters. Scientists previously believed that if Ceres had a high ice content, its craters would quickly deform, behaving like honey or flowing glaciers. Since NASA's Dawn mission observed many well-preserved deep craters, researchers initially concluded Ceres couldn't be very icy. But the Purdue team discovered something surprising. When ice is mixed with even small amounts of rock, it behaves quite differently than pure ice. Even solids will flow over long timescales, Pamerlow noted. Ice flows more readily than rock. Craters have deep bowls which produce high stresses that then relax to a lower stress state, resulting in a shallower bowl via solid-state flow. Their models revealed that a gradational crust, with higher ice concentration near the surface gradually decreasing with depth, could maintain crater shapes for billions of years without significant deformation. This structure perfectly explains what the Dawn mission observed during its exploration of Ceres between 2015 and 2018. The implications are profound. Rather than being just another large asteroid, Ceres now appears to be more similar to the ocean moons of the outer solar system like Europa and Enceladus, except with a muddier, dirtier composition. The key difference is that Ceres' ocean has likely completely frozen over time, preserving a record of its aquatic past in its icy shell. Perhaps most exciting is what this means for future exploration. At roughly 950 kilometers in diameter, Ceres is substantial enough to have developed many features of larger planetary bodies, including craters, volcanoes, and landslides. As Sorey enthusiastically noted, to me, the exciting part of all this, if we're right, is that we have a frozen ocean world pretty close to Earth. Ceres may be a valuable point of comparison for the ocean-hosting icy moons of the outer solar system. Ceres, we think, is therefore the most accessible icy world in the universe. That makes it a great target for future spacecraft missions. Those bright, enigmatic spots on Ceres' surface that puzzled astronomers when first observed by Dawn? They're likely remnants of that ancient ocean, materials erupted onto the surface after freezing. These regions could offer incredible opportunities for future missions to collect samples from what was once a living ocean, all without traveling to the far reaches of the outer solar system. As we continue mapping water resources throughout our solar system, Ceres stands out as a potential treasure hiding in plain sight, an ancient ocean world disguised as a humble asteroid waiting just beyond Mars for our return. The story of Ceres is just one chapter in our solar system's surprisingly wet narrative. While Earth has long been considered the water world of our planetary neighborhood, we're discovering that H2O is far more common throughout space than we once believed. It just takes different forms depending on distance from the sun and local conditions. Take Europa, one of Jupiter's 4 large Galilean moons. This ice-covered world harbors an ocean containing an estimated 2 to 3 times the volume of all Earth's oceans combined. Unlike Ceres' frozen waters, Europa's subsurface ocean remains liquid today, heated by tidal forces from Jupiter's massive gravitational pull. Its smooth, cracked surface betrays the movement of liquid water beneath, making it one of astrobiologists' prime targets in the search for extraterrestrial life. Saturn's moon Enceladus presents an even more dramatic case, actively venting water into space through geysers erupting from its south pole. The Cassini spacecraft flew directly through these plumes, detecting not just water but also salts, ice grains, and organic molecules. Even more exciting was the discovery of hydrothermal vents on Enceladus's ocean floor environments that, on Earth, teem with life despite complete darkness. Ganymede, Jupiter's largest moon and the largest in our solar system, possesses a subsurface ocean estimated to be around 100 kilometers deep, with several layers of ice and liquid water arranged like a cosmic onion. Similarly, Callisto may host an ocean up to 150 kilometers thick beneath its heavily cratered surface. Even Titan, Saturn's haze-shrouded moon, has a unique water story. Its surface features lakes and seas, not of water but of liquid methane and ethane. Yet beneath this alien landscape lies a hidden subsurface water ocean, likely 50 to 100 kilometers deep. Further out, Neptune's moon Triton shows evidence of subsurface liquid water mixed with ammonia, which acts as antifreeze in the frigid outer solar system. Pluto, too, may harbor a 100-kilometer thick subsurface ocean, kept liquid through insulation from gas hydrates and internal heat from radioactive decay. What makes Ceres unique among these worlds is its location. While Europa, Enceladus, and the others orbit gas giants in the outer solar system, Ceres sits relatively close to Earth in the asteroid belt. This proximity makes it, as Mike Sorey put it, the most accessible icy world in the universe. The widespread presence of water throughout our solar system reshapes our understanding of planetary formation and evolution. It suggests water-rich bodies may have been common building blocks of planets and raises intriguing questions about where Earth's own water came from. Did comets, asteroids, or Ceres-like objects deliver it? More importantly, these discoveries expand our conception of habitable environments. If liquid water can exist in so many places beyond Earth, from the asteroid belt to the frigid outer reaches of our solar system, perhaps life too might be more adaptable and widespread than we've imagined. Finally today, a topic our listeners raise with us on a regular basis. Mars, the red planet that has captivated human imagination for centuries, might be closer to becoming a second home for humanity than we previously thought. New research published in Nature Astronomy suggests that terraforming Mars, transforming it into a habitable world, could be more feasible than earlier studies indicated. Led by Erica Alden de Benedictis from Pioneer Research Labs, the study highlights 3 key advances that have changed the terraforming conversation: dramatically improved climate modeling and engineering techniques, breakthroughs in understanding extremophilic organisms and synthetic biology, and significant developments in space technology, particularly SpaceX's Starship, which could potentially reduce payload costs to Mars by a factor of 1,000. What's particularly interesting is that comprehensive research on Mars terraforming feasibility hadn't been substantially updated since 1991. This new paper outlines a 3-phase approach that could potentially transform the red planet over time. In the short term, we now know Mars possesses sufficient ice reserves and soil nutrients to potentially support life, if temperatures could rise by at least 30 degrees Celsius. New warming methods look promising, including solar mirrors, engineered aerosols, and surface modifications using materials like silica aerogels. These appear more efficient than earlier proposals, and, combined with our increased launch capacity, could potentially warm Mars enough within this century to permit liquid water and support the first extremophilic organisms. The mid to long-term vision would involve introducing pioneer species engineered to withstand Mars's unique challenges: low pressure, toxic oxychlorine salts, extreme temperature swings, intense radiation, and scarce water. These hardy organisms would initiate ecological succession, gradually transforming the planet's chemistry and potentially beginning oxygen production. While initial human habitation would still require protective environments, the ultimate goal could be creating a 100 millibar oxygen atmosphere, sufficient for humans to breathe outside without pressure suits. Most remarkably, this atmosphere could be created entirely from resources already present on Mars. This transformation would take hundreds of years, but the research suggests a sustainable, ecologically minded approach. Rather than diverting attention from Earth's environmental challenges, Mars terraforming research could provide valuable insights for planetary sustainability. Technologies developed for Mars, like desiccation-resistant crops and improved ecosystem modeling, could benefit our home planet as well. Of course, ethical questions abound, particularly regarding potential indigenous Martian life, which should be thoroughly investigated before any large-scale terraforming begins. The researchers emphasize that Mars could serve as a crucial testbed for proving scientific theories about planetary engineering, knowledge we might someday need to preserve Earth's habitability in the face of our own climate crisis. While full transformation would take centuries, the research suggests the first steps could begin sooner than many have assumed, marking the beginning of humanity's potential expansion beyond the blue boundaries of our homeworld. Well, what a journey through our cosmic neighborhood we've had today. From launch pads at Cape Canaveral to the distant possibility of a green Mars, our solar system continues to reveal its secrets and possibilities. Each of these stories represents another piece in our expanding understanding of the solar system, a picture that grows more detailed, more surprising, and more promising with each new discovery. This has been Astronomy Daily. I'm Anna, and I hope you'll join me again tomorrow for our next journey through the cosmos. If you'd like to stay up to date with all the latest space and astronomy news, visit our website at astronomydaily.io, where our constantly updating newsfeed brings you the universe in real time. Subscribe to the podcast on Apple Podcasts, Spotify, and YouTube, or wherever you get your podcasts. And don't forget to follow us on social media. Just search for Astro Daily Pod on Facebook, X, YouTube, YouTube Music, Instagram, Tumblr, and TikTok. Until next time, keep looking up. The universe is an amazing place, and we're just beginning to understand it.